All right, I think now we are going to get started. Thank you everyone who is attending this webinar. This is an InfiPoints Introduction webinar that was put together in collaboration with our customer, BC Engineering and Design. My name is Danielle Williams. I am the Customer Engagement Specialist out of the Southfield, Michigan office, and I am joined by my technical team member, Nate Spoulier, who is the Application Support Specialist, also out of the Southfield, Michigan office. So before we get started, just to let everyone know, please submit your questions through the chat window. We'll be answering questions at the Q&A at the end of the webinar. So without further ado, let's get started.
Here's a quick look at the agenda for today's webinar. I'll be doing a brief introduction of Elysium and product technology. We'll get into InfiPoints functions with demos. We have a couple of case studies we'll touch on, and of course we'll leave time at the end for Q&A. So a bit about Elysium. We have over 30 years of CAD expertise that we have leveraged to develop high-quality solutions. We keep very strong partnerships and relationships with most of the major CAD vendors, which is important for a couple of reasons. One, we do utilize the APIs in our translation software for a higher quality, higher fidelity translation, but we also want to keep strong relationships so that we know what their customers are asking for, so that we can continue to develop our solutions to support their needs and their customers. We are mainly known for our translation and healing capabilities. We also have quality management and checking, very robust validation solutions, simplification and optimization of data, and more recently, we've dove into reverse engineering and point cloud rendering. We do offer our software off the shelf. We OEM it, and we do provide migration services when applicable. Taking a look at our map to the right, we are out of the Southfield, Michigan office. We have a development and R&D office in Huntington Beach, California. Elysium is headquartered out of Hamamatsu, Japan, and we do have 2 offices in Europe, one in France and one in Germany. Within our solutions, we support much more than just geometry translation. We maintain product structure, support 3D PMI or annotations. We can support attributes. We do have feature-based translation capabilities as well. Beyond what we can translate, we also have optimization and simplification tools. The validation solution I mentioned, you can validate translation or track engineering changes. Quality checking and healing, not just checking the quality of a translation, but checking the quality of data for downstream purposes. We have polygon operations and healing, and then of course point cloud handling with InfiPoints that we'll be getting into more today. So now looking into scanners and point clouds with getting into InfiPoints. There are many different types of scanners around. There are your short-range scanners more for parts and product scanning, mid-range scanners for plants and vessels, long range with construction and engineering, and then your city-wide long range more for geographical scanning. We see a pretty high demand for InfiPoints within that mid-range and long-range scanner categories. Of course, InfiPoints can support all the different scanning capabilities and categories, but those are the 2 we see the highest demand. So what is InfiPoints? It's a large-scale point cloud handling tool which can be used for various industries and fields. To name a few of the main industries we see a high demand in: shipbuilding, plants, manufacturing, construction, and architecture. There are many other industries that we can support, but these are the main ones we've seen pretty high demand. The concept behind InfiPoints was to provide a one-stop solution for all the point cloud handling processes to streamline the workflow. What used to take 4 to 6 software tools can now be done in one with InfiPoints, eliminating time and many translation steps. Our main goals behind InfiPoints was to reduce the amount of time needed for data preparation and to be able to smoothly work in a large-scale environment. Point cloud data can be extremely large and difficult to navigate, but with InfiPoints and its multiple automatic functions, it makes it easy to handle billions of points. Some use cases that point clouds are used for in general: digital measurements, being able to easily measure equipment and facilities without the dangers that can come with hand measuring. Layout planning with simulations, being able to clip out, remove, and examine equipment before or after construction. CAD modeling, automatically extracting planes and cylinders from point clouds, and modeling in general using an existing environment. Equipment and placement, using the point cloud to perform collision detection with the existing facility without having to physically be there and move equipment around. So the conventional workflow, everything was done by hand, which can be very time consuming. With the introduction of utilizing 3D laser scanners, there was a reduction in time for this workflow, but more could be done, and that's where InfiPoints comes in. The introduction of InfiPoints into a workflow greatly reduces point cloud processing time. On average, we've seen a 50% time reduction when InfiPoints is added to these workflows. Now we're going to get into the different functions of InfiPoints that support these 5 processes: data import, data pre-processing, analysis, modeling, and the various outputs available. Starting with data import, InfiPoints can handle multiple scan data formats, including native scanner data and large-scale point clouds. With InfiPoints, you're able to take 2 different kinds of scans, for example, a scan taken with a tripod scanner and a scan taken with a mobile scanner, and register them to create a unified environment within InfiPoints to work with. Onto pre-processing data. We do have automatic registration within InfiPoints. This can be utilized when using targets. However, we also have markerless registration when targets are not used. InfiPoints will automatically align the scans during registration and also provide additional tools for manual adjustments if needed. Once the registration is complete, a validation is run on the registration, and an XML report is created to show what happened in the registration. And now I'm actually going to turn it over to Nate, who is going to show an example XML report.
Thank you, Danielle, and thank you to our customer, BC Engineering, for providing an example XML report from commercial use. The XML report is a tool used for recording the accuracy of our automatic registration process. It contains several forms of information, including overview images showing scanner locations and subsequently showing how the scans were paired together for the process, followed by evaluations by extracted planes, including the location of the scan origin within the global environment, as well as the gap between the extracted planes that were used to register each individual shot. All of these evaluations are then broken down into histograms and color maps for viewing and clearer understanding. Now I'll give the presentation back to Danielle.
On to noise reduction. InfiPoints has automatic noise reduction or removal, where it will automatically remove overlapping noise where there are duplicate points, as well as kinetic noise, where, for example, someone walked through the scan during scanning. It will automatically remove objects like that from the scan. And now Nate is actually going to show an example of noise reduction.
Thank you, Danielle. As mentioned, InfiPoints has a powerful automatic denoise capability that requires minimum user interface to set the thresholds for the noise capture and to set target layers for the identified noise. Once the denoise process is complete, we can see that a significant portion of the data within the environment is automatically recognized as noised, and by hiding the noise layers, we can lighten the environment for further needs, such as modeling. And now I'll return the presentation to Danielle.
InfiPoints has multiple analysis capabilities. Digital measurements can be performed in the environment. Here, you can actually use the automatically extracted planes and cylinders to take a measurement either from the edge or center of a cylinder to the floor, for example, for a more accurate measurement, instead of having to actually pick out an individual point to measure. Collision detection is a great tool for planning the installation or removal of equipment. You can perform the interference checking along a predetermined path, or perform dynamic collision detection where you can drag a CAD model or mesh through the environment in real time to see where it interacts with the existing environment, which Nate is actually going to demo for you now.
Thank you, Danielle. At this time, I will demonstrate collision detection using both dynamic and path-defined methods using a polygon mesh generated from a clipping box of our machine room sample environment. Along with using the polygon mesh, we can perform collision detection using imported 3D CAD models. Once collision detection is activated, we can select the 3D geometry we desire, and then, using the InfiPoints interface, move the object in the environment. While the object is colliding with the environment, it will be translucent, which allows the user to best visualize each of the points of collision highlighted in red. Our second method is to move the object along a defined path, which I have prepared for a demonstration, to represent removing the mesh pump from the machine room. The pump becomes opaque to signify that it is no longer colliding with any of the points. And now I will return the presentation to Danielle.
There is also the function to run a comparison between CAD and point cloud. This will show where there might be deviations in the existing environment. This can be performed using the automatically extracted planes and cylinders against the point cloud to see where there may have been wear and tear over time, where equipment may have warped, or you can import an external CAD model to perform the comparison against the points within the existing environment from there. Onto modeling. It's possible to create a mesh of a piece of equipment that is in the environment. You utilize the clipping box feature in the point cloud to isolate the piece of equipment that you want to create the mesh of. This can then be put on a different layer within InfiPoints. And then InfiPoints will generate a mesh of that piece of equipment. That mesh can then be used for collision detection of removing a piece of equipment, or it can be exported to be used in other downstream processes or analysis. For pipe modeling, InfiPoints automatically extracts piping and cylinders, but also gives you tools to complete piping runs or model new ones. Standard piping specs can also be utilized during this modeling. Nate is now going to demo some pipe modeling.
Thank you, Danielle. What is great about the pipe modeling tool within InfiPoints is its versatility without the need to return to a CAD system for initial modeling. For example, InfiPoints allows for the creation of pipes based on the point cloud that may not have been automatically recognized just by selecting 2 points. From there, pipes that were automatically extracted in independent segments can simply be merged together by selecting 2 or more cylinders that are of similar diameters and lie on the same axis. It is also possible to clean up lengths of pipe that were extracted as several smaller segments by just joining them together. InfiPoints also has a variety of possible connections, including elbows, that are easy to apply by selecting 2 straight pipe lengths. Unfortunately, we do not have the time right now to fully explore all of the capabilities found within the InfiPoints modeling tool, but we would appreciate the opportunity to follow up with individual inquiries in detail after the webinar. And now I will return the presentation to Danielle.
Equipment modeling within InfiPoints. You can use the automatically extracted planes to build the outer structure of a room within the scanned point cloud environment. The auto-extracted planes can also be used to model equipment in the room by selecting the planes that make up those pieces of equipment. You can then cut a 3D cross-section to then be used to create a 2D drawing. Freely measure dimensions in the drawing, angles can be calculated, and the 2D and 3D model can be viewed as a hybrid view. Steel structure modeling is possible within InfiPoints. The auto-extracted planes can be used to specify an H-beam or I-beam. You grab the outer and inner planes of the targeted beam, determine the length of the beam that you're targeting, and then InfiPoints will insert a steel structure to complete the steel beam of your choice. Once you've finished with your modeling or other functions, InfiPoints has various types of outputs supported. A highly precise ortho image can be exported that can include dimensions. Fly-through video creation is supported. You can create a video by specifying several viewpoints. This is great for collaboration and sharing environments amongst multiple groups. One export that I really like to emphasize is the viewer file export out of InfiPoints. We can reduce the point cloud to create a lighter 3D environment and export it out to this file that can be viewed without licensing. CAD models can be included in the environment, previously measured dimensions, notes. You can then restrict or allow other viewers to take their own measurements, export a 2D drawing from the file, or even add their own notes for collaboration. And Nate is going to show a quick example of one viewer file.
Thank you, Danielle. The first point to make about our viewer file output is that it can be shared for collaboration with anyone. The viewer file is a standalone output that does not require additional licensing. However, all the information from the main InfiPoints environment is maintained per the user's discretion. Not only is the point cloud exported for viewing, but any CAD model, extracted or otherwise modeled features from the planes, cylinders, and steel structures, as well as 3D drawings and 3D dimensions are maintained in the viewer for collaboration. Along with maintaining what was created, the viewer file allows for additional 3D dimensioning, including dimensions between InfiPoints models, imported CAD models to the InfiPoints environment, as well as point-to-point from the point cloud. It is also possible to create 2D drawings from the viewer file, including the capability to sketch features that were not automatically recognized and then add dimensions as required. Another great feature found in the viewer file that can also be found in the host InfiPoints environment is the ability to add hyperlinks to web pages and attachments from local documents to help keep track of maintenance or purchasing schedules, to name a couple of examples. All of this information is stored within the viewer file for powerful collaboration within your own company from user to user, but it's especially helpful when working with customers or suppliers who do not yet use our solution. And now I will return the presentation to Danielle.
External links can be utilized in a viewer file or the InfiPoints environment. Manuals can be attached, spec sheets can be added, or even hyperlinks to a web page can be embedded into the file or InfiPoints. InfiPoints also supports the export of a multitude of scan formats, CAD formats, mesh and polygons, and formats that can connect to other software and processes like BIM software. The next upgrade of the InfiPoints coming at the end of the month will include the first stage of support for virtual reality with the Oculus Rift. Further enhancements will be coming with the following upgrades at the end of the year. This point cloud web viewer is a concept that our development team is currently working on today. This would allow point clouds to be hosted on a server and could be displayed on tablets or smartphones. To finish up, we have a couple of case studies to mention from actual InfiPoints customers. This is an examination of inclines on a concrete floor. The CAD to point cloud comparison was used to see where the inclinations in the concrete floor were to better plan for the implementation of new equipment. This last one I'll touch on is a customer that used the automatic extraction of pipes along with the further pipe modeling tools to create the existing pipe runs and see where they connect with the existing equipment in order to estimate the construction of new pipes to renew the piping lines.
So that is the main topics we wanted to touch on today. We do have a couple other use cases that we can touch on if there's time after questions. However, we wanted to thank everyone for joining us today. We also again wanted to thank Tommy Maddox with BC, our customer, BC Engineering and Design, for collaborating with us on this presentation. So right now we're going to just give a couple of minutes for people to submit questions through the chat window of the GoToWebinar. So please feel free to ask any questions at this time and we'll begin answering them shortly.